Getting ready to start the second panel. Our first speaker this panel is actually an online guest. Unfortunately, she couldn't come here in person, but she's a person I admire a lot, Emma Hooper from Building Smart UK and Northern Ireland. And she's actually she written an article in AEC magazine about the importance of information in buildings and having information and seeing it as an asset, not only a tool, but actually an asset and a golden thread. The phrase with the golden thread, which is information, is one I usually like to cite in my different presentations, and of course I always mention Emma's name when I do that. So I hope we have her online on Zoom and she can hear us, and I hope we can also hear her. So let's see what happens. Hey Emma.
Hi Stefan, how are you?
I'm great. We can hear you, we can see you. Awesome.
That's good.
Awesome.
It's working.
Welcome to BIMcon.
Thank you for having me. Sorry I couldn't be there in person, but I hope you're having a good time.
No problem. So Emma, I think you have a presentation for us. I'm gonna leave you to it.
Okay, let's hopefully this will work. Can you see my presentation okay? I'll take that as a yes.
Yes.
Right. Hello everyone. So welcome to my presentation on IFC and how we can apply it to information management. So as Stefan said, my name is Emma Hooper. I'm Head of Information Management Strategy at RLB Digital. We're a subsidiary company of the wider RLB business, and we focus on external facing digital services. And my role is around ideas, working out the intricate details of information management and its application to help organisations and projects. And then there's my other role, where I do the joining up and bigger picture thinking at an industry level through my roles as Vice Chair of both Building Smart UK and Ireland and NEMA. And if you've seen my presentations before, you know I'll always start with this word, information, because I want people to view and think of information in a different way, in a way that it deserves, not only because I think it's a fascinating subject in its own right, but it also fundamentally shapes every aspect of our lives, our reality, and is key to unlocking digitalisation. Yet we hardly think about it, which, if you think about it, is a bit crazy and scary. And what I'm going to talk about is underpinned by my favourite subject, information science, which focuses on the principles, structure, quality of information, and how it works within a system. It's about things like taxonomies, ontologies, and knowledge graphs. Viewing information from this angle is what I'm certain will lead to better information management and interoperability within our industry. So as an industry, we need to start viewing information as an important asset in its own right, on par with a physical built facility. And this all starts with the asset owners, the clients. Clients procure buildings, bridges and roads, but they also procure the information that relates to them, which is just as important. And if that information is received in a way which is useful and there are processes in place to manage it, it can provide great value to organisations. And this is what helps built assets stay safe, reduce their impact, and allow sound business decisions to be made. But to do this, information management within organisations needs to be given more attention and resources than it currently does, and defined before any projects or other appointments take place. Clients are the most important actor in information management as they provide the inputs and set up the framework. And for me, because I'm biased, I say it's the one true asset to rule them all. So for this presentation, I'm going to break it down into these sections. So I'm going to start a bit about information management and then look at both layers, the management layer and the information layer, and that's where I'll cover IFC. Then I'm going to finish with information modelling and then just to sum up. So let's start with information management. What is it? So information management enables us to find, share, use and query our information in an easy way to ultimately gain insight. And when I describe information management, I will start with this slide. So across an asset's life, there is both an activity-based management layer, which people interact with, and secondly, an information layer, and this is the layer which technology mainly interacts with. Hey presto, you have information management. That's all great, but this is what we have now, a tangled and highly chaotic web of stuff. Incorrect, incomplete and lost information introduces so much risk to projects and organisations, yet for an industry obsessed with risk, we barely ever think about it. And as we create more data, develop new standards, processes, technologies, and form new initiatives, this beast is growing and getting more tangled by the day. Over the years, in the built and natural environment, there has been an increase in the need for information from best practice, standards, policies, and regulations. And this has resulted in more and more information and data being produced. And we can produce vast amounts of information quite easily and readily. Technology allows us to do that, but the quality is what is lacking, and the trust, and the fact that it overlaps, contradicts, and is duplicated. Because on the face of it, although our technology has evolved substantially, our maturity with regards to information is not. So we're guided by technology and not by the information itself and the science behind it. If we think of the industry as a tree, the top part is the information and data which is growing rapidly, chaotically, and getting bigger by the day, in comparison to the small roots which represent what we have in terms of understanding the science part. A tree with weak roots will not only impair the growth above, but it will also become unstable. And my worry is it will become too chaotic that we can't unpick it. But hey, we'll just get AI to sort it out for us. But we've seen time and time again that applying technology on its own, uncontrolled and unsupervised, doesn't work. And in this scenario, my worry is it removes us even further away from understanding it, with the same questions around quality and trust. We need to do the groundwork to make those roots bigger. We need to understand the science, join it up and work towards a universal bigger picture. But from the technology perspective, since the introduction of CAD software, the language, structure and rules of the software have been the ones used in helping to define the information for an asset, which is often poorly considered. And bring this forward to the era of BIM, and it's only gotten worse. Software applications are tools which process information. They should never be used to define it. The structure and language of information should be defined outside of software, considering the bigger information management picture, and it should also be neutral and it should be open. Therefore, information should be defined independently of technology applications. And I'm not saying technology is bad, of course it's not, but it needs to fit into the natural flow of information and not try to change it for its own short-term benefit. So that sets the scene. Now let's look at each of the two layers separately. So we'll start with the management layer. And with this, we'll start with the standards of ISO 19650. So if I could summarise what takes place in this layer, it would be cycles of these activities shown, which are appointment-based, not work stage. So basically, for each appointment, we have to specify what information is needed, use this to select the right suppliers to deliver the information. Next, the suppliers plan the delivery and deliver the information where it's assured against the original requirements. That's hosted within a store, and then the information is presented or visualised for reporting purposes and used or exploited to manage projects, assets, or the organisation. We're all familiar with the creation and maintenance of the physical asset, but what ISO 19650 is doing is providing a framework for the creation and maintenance of the virtual information asset. So that was a summary of the management layer, but across all those activities, the information needs to be named, ordered, structured and connected in the same consistent way, and this is the job of the information layer. So in the information layer, there are many standards, and this includes some of the ones shown, but there are many, many more. And within this layer, it's important to understand why standardisation is required. First, if we revisit what I talked about at the start, focusing on a technology-first approach has created this point-to-point scenario where data has to be transformed and translated as it's passed on. And this was bad enough when there were only a handful of software applications. Now we have many, and this is only going to grow, which gives us hundreds of potential permutations. And what's more, we're locking information away in a bespoke proprietary languages, which always needs an application to access it, which isn't guaranteed. Data has to live at least as long as the asset. But that's only the start. If we drill down further, as end users start to adopt more data-based ways of working, we have the scenario where each user will have their own bespoke data structure, even though they'll all be very similar, and this creates limitless number of permutations and an interoperability time bomb waiting to explode. There needs to be a longer-term sustainable solution to this exchange problem. So what's the answer? Well, we put the information first, so it's the software which serves the information, not the other way around. We open up the information, so not limiting which software applications can plug in, and we use a standard approach so the data doesn't require so much transforming. So rather than this point-to-point scenario, we get this. A baseline information layer which spans an asset's life, containing all the structures, rules, and language. And as I've said, to enable information to be shared, this needs to be standardised. Therefore, we need to add to this statement, and it's this standardised approach that really helps us start to untangle the chaos that we saw earlier. The information within the information layer is complex. There's no getting around that. It's structured, unstructured, multifaceted, hierarchical, connected in many ways, and the view of it changes according to its use. Standardising this is key to increasing interoperability. And as shown earlier, there are several standards that occupy this layer. However, taking centre stage and to give us any chance of joining this up, we need to use an object-based approach because it's the objects that connect everything, an approach which utilises a schema and data models. So do we have such a standard? Well, we do, and it's ISO 16739, or Industry Foundation Classes, or IFC, which provides the object structure in the information layer. This is managed by Building Smart International, a non-for-profit organisation. And I come across a lot of misunderstanding and misinformation about IFC, so my mission is to help clear that up and explain what it really is. In basic terms, it sets out how objects or things are ordered and how they relate to each other. Humans see buildings and infrastructure as physical things, and we know that windows are in walls and columns are connected to beams. A computer, though, needs to be able to understand the same things via a computer language, and that's what IFC is kind of doing. It's a digital representation of a facility. IFC 2x3 is still the predominant version used, especially in the UK. However, we do need to change this and move away from it. IFC 4.3 was released as an official ISO standard early in the spring, and this has a much more consistent structure, and it also includes infrastructure entities. And I actually think infrastructure actually has the real potential to overtake buildings on its use. So the standard of ISO 16739 is actually free and it's a website. And this is because it cannot be written down really as a traditional PDF document. And all versions can be found on the IFC specifications database webpage, which you can use this QR code to get to. So at its core is an object-based data model which provides the rules to give everything a unique place and to connect it all up. It contains three important parts: entities, attributes, all linked via relationships. And these entities can cover anything from a door, a system, a whole facility, a task, an actor, and some represent geometry. And then there are some entities which allow us to connect to the outside world, so we can link documentation to objects. We can link external databases, which will contain their own data models and dictionaries for things like product manufacturers' data, and we can add classifications to give it a local language. So IFC allows us to digitally represent this. An instance of a pump is associated with space and a pump type. Space is located on a building story, and it may be part of a zone. The story is part of the facility, and that sits on a site. The pump will also be part of a system and be connected to pipe fittings. It will have detailed classification assigned to it and also be referenced in documents. It will have basic information like name, description, ID, and performance properties like pressure. It can be associated to entities for task, time, and resource to do sequencing, programming, and logistics. And then we have geometrical entities, so we can visualize in 2D or 3D, but technically speaking, it doesn't actually have to have geometry to exist as data. Connecting all of this is what IFC allows us to do, and there's nothing else in the built environment that can do it at this scale. From this, you can see it's the relationships that make IFC so powerful, and we need to start thinking of them as being just as important as the entities or the objects. IFC is a flexible framework of connections to create models of data. And this is what a tiny part of the schema looks like, and to most this will just look like gobbledygook, and that's fine, because it's a computer that needs to read it and not people, and this operates in the back end of software. People should only really see the data visualized as information. And this can be dashboards, tables, data sheets, 3D models, even construction drawings and text documents. The important part is to structure the data in accordance with the IFC schema, and it can be used and displayed in so many ways, because we all consume information differently. An issue that we've had is that software currently exposes too much of the complexity to people, where it should be really shielding them. And since construction is still currently file-based, we exchange IFC models by creating a file to put the data into. And when you create a file, you need a file format to package the schema up into a file language. And for IFC, there are several exchange formats. The main one we exchange is the step physical format, which is text-based. And because it confusingly has the .ifc file extension, this has caused a big misunderstanding that many think IFC is just a file format and not an entire data model and schema. And there's also XML as well. And then there are another 3 in development for linked data. I also wanted to touch on the open source movement, which is an amazing collaborative community of individuals who develop free tools based around IFC. And if you want to know more, visit this link, especially look at the forum. And part of this community, there have been 2 significant software libraries which have been developed. The first is IFC OpenShell, so this provides a way of reading, writing and processing IFC models in native desktop applications, and this is what underpins Bonsai or Blender BIM, and IFC.js, which provides a way of reading, writing and processing IFC models directly in a web browser. So let's go back to information management, and IFC is a data model that has the potential to join up the information layer. In fact, all the activities in the management layer are to enable the planning, creation, updating and maintenance of connected data models across the life of an asset, using standardised schemas such as IFC. And for effective information management, we need both layers working together. That's really important. And I'm going to talk about these data models or information models in the next section. So information models. So this connected information I've just talked about is described in ISO 19650 as an information model, but this is where we always go wrong and where I'd love to start to change people's perceptions, because at the moment what we deliver isn't connected. It's a dump of separate drawings, documents, spreadsheets, 3D models and data that don't relate to each other, and the majority of the information is trapped in files. So rather than having CDs as they currently are as document management systems, we can start to release the trapped data from files and put it directly into the CD database, where we can connect it with any remaining documentation, so we can start to find, share and query, not using huge monolithic files, but discrete data. So let's think about what this information model concept could look like in the context of the built asset. And this starts with a new build project in the physical world. And although in the physical world, the actual build part is a long way off, in the virtual world, the model is started from the very outset. At this point, we might know the location of the site, the area, and what the name of the facility will be. And this is a very small model. So the small model, together with information requirements, is passed to the designers, where they create the base object structure using their authoring tools to design and analysis tools to refine. So the model of information starts to take shape. The owner will need parts during a project to satisfy purposes, so there are several handovers throughout, not just one at the end. So next, let's build the physical facility. So for this, we'll have new information which enriches the base information that the designers produced, like warranty, commissioning and installation information, including evidence documentation. And this is where we have issues, because currently we only write to the information model through the design authoring tools. So we end up going backwards and asking designers to add data they're not responsible for. We need a way of writing to the model by enriching what's already there. So what happens next? Well, for final handover, the project information model is issued to the client, where the required information is extracted and merged into that asset information model, which is a database of all the information they need for their purposes. But it doesn't stay still, as it's constantly changing as trigger events occur, many at the same time. So for example, a pump breaks down. So now what? Well, the pump information from the model is made available to the maintenance engineer, together with information requirements. In the real world, they replace the pump. So in the virtual world, they update the information which has changed, the manufacturer, model number and warranty. And this could all be done by simply filling a form. It gets checked and it's merged back in. So it's not changing the entire model, it's just changing a few bits. And this is the current state of the facility. The data can be visualised for reporting and used by other enterprise systems, and even connected to smart building-based data models and as the start of a digital twin. At the end of life, if objects objects were to be used in other facilities, that object and its data could potentially transfer into another asset information model, contributing to that circular economy approach. So basically, as that object-based specification, IFC with other data models and standards have the potential to be used so all processes use the same consistent information layer throughout. A common data or information model, from specifying information requirements to in-use and very importantly checking. So the more we can control and standardise the information layer, the more we can automate stuff like checking, and we can start to improve the accuracy of generative AI as well. So we can check the delivered information models against the original requirements, and this is where information delivery specifications or IDS come in. And this makes exchanging machine-readable information so much more efficient, and having a robust data dictionary as a foundation, so there's one structure throughout, and this provides the interoperability and certainty we really need as an industry at each point of the asset's lifecycle. So just to sum up, I've talked about the information layer and how it needs to be formed of information or data models defined by open schemas such as IFC. And this ensures the information layer is standardised and importantly independent of software. Therefore, users are free to use whatever tool they wish, and the data can freely flow in either direction without barriers. And for me, this is the data model for the built environment. This model has to be managed by a non-for-profit organisation, not associated with any technology product, and governed by international standards. This ensures it is accessible and held accountable by the industry, because this base model is key to everything as we become more reliant on data. And there is a power shift approaching, one which moves away from the software itself to the data structure, and industry needs to be in control of this. So just to finish, these are some of the things that IFC is not. So it's not a rival of Revit, it's not a dumb file format, it's not a classification system, it's not just about 3D models, it's a model of data. It's not just about walls and columns and boilers. We can do processes, we can do bring in actors, organisations, lots and lots of other things. And it's not just about adding properties to entities. We have to utilise the power of those relationships. But what I do believe is it can be the independent data model for the built environment, which starts to join up that data. And I just wanted to end by saying tomorrow, Greg is going to be talking about the future of IFC. So he's going to be talking about IFC 5, which has a completely different data architecture to what we have now. So yeah, I would definitely say don't miss that. So that is me. If anyone's got any questions, thank you very much.
Thank you so much, Emma, for an amazing presentation explaining pretty complex concepts into a very visual, graphical, easy to understand information. I'm not sure if you can stay until the end of this panel, so I'm just gonna ask you a quick question. I was wondering if you could evaluate what is the value of the information model inside the project. So have you ever tried this, I don't know, mental exercise? What is the actual value of that information if you see it as an asset or an object?
I can't quite hear you, Stefan.
Let me try again. Can you hear me now? I hope you can hear me.
No, sorry.
No? Can you hear me? Nope, nothing?
Oh, I can hear you now.
Yeah, great.
Yeah.
So I was just asking you a quick question. I know you can stay until the end of the panel. So what do you think is the value of information as an asset? So I don't know if you ever thought about it, but can you put like a percentage of the total value of a project or something like that?
I've never thought of it in those terms. I think things like that are sometimes very hard to quantify, really, aren't they? Because it just depends on different situations. But I mean, one of the things I really do want to push is that, when we talk about information management, it is all about business at the end of the day, and the value of the asset of information to the business. And what we see a lot of the times is that BIM consultants will be brought on board to start to define this at a project level, but really the organisations have to look at this internally first within their business strategies, and really look at it in terms of every other asset they have. But yeah, in terms of what it is in a figure, I wouldn't like to guess.
Do you guys have any questions for Emma? You want to ask her something? Does anybody have a question? Just top the top of the head. Yeah, we have a question over there. Can someone please?
Hello, Emma. Can you hear me?
I can hear you, yes. Hello.
Hello, my name is Marin. I have a question, if you can help us out. Can you give us a very simple example of how a Building Smart data dictionary could be used? Because we started understanding the IFC, we started understanding the IDS, but the BSDD is not very clear. Let's say, for example, we have a requirement where we need all the walls in the project to have a fire rating parameter. And we can specify this by the IDS, and we need to find it in the IFC. How would we use the BSDD? Thank you.
So fire rating, if you're using that example, that's actually in the IFC schema, so it's a common property, so you don't really necessarily need to get that from the BSDD, but you can do it, isn't there? The BSDD is there to start to bring all properties together, so ones that are in the IFC schema, but other properties that might be in other dictionaries elsewhere, or bespoke ones that a client has, for instance. So it's to start to build up an overall place, really, for all the properties. So we don't have the scenario where, one person calls it fire rating, another person calls it fire rating with a space in between, or fire rated, or, there's loads of different combinations of terms that we use. And it's to try and get a bit more standardization and look at then maybe that fire rating, does that connect to any other properties that are similar or anything like that? That's what it's trying to do. It's trying to bring those sort of terms together, so they're not spread out, and we can start to then see the relationships between them. I think it's still quite early days with regards to the BSDD and the power of it, and I actually think as we go forward, that's probably going to be the most powerful part of all of this. But we need to really get that part right. And it's been something I've been thinking about in terms of data dictionaries and semantics and things at the moment. But I think as an industry, we've got a little bit of a way to go yet on the data dictionary side, but getting there. And the BSDD will become very, very valuable.
Thank you very much, Emma. Thank you for your presentation and for your time. Talk to you soon. Bye-bye.
Okay, thank you, everyone. Enjoy your time. Right, bye.